All right. Sorry about that. Okay. So welcome to the Carpenter Working Group. I see that we have a few questions and then some project updates already. So why don't we get started with the project updates? Share my screen too. Um, Azure release. Does anyone want to provide an update on this?
It's not much to say, just link to the release notes. There are lots of new stuff and catching up with the core 1.4. The rest is in the release notes.
Yeah, it's awesome. Any questions on that? Um, no. Let's move on to RFCs, node overlay. Manuel, you have anything to share?
Yeah, we're getting pretty close to merging it. Hopefully, if anybody has feedback, please do give it. We're targeting to try to merge the RFC sometime next week, probably early next week, depending on how things go. The only last remaining topic or point of conversation is where exactly we want to surface these overlays. Um, we're probably not chances are we're probably not going to change our position on this. And so, yeah, if anybody has any feedback on any of the talking points or comments on the RFC, please do feel free to go and add some. Also, if you have any questions, please do reach out as well. Thanks. Yeah, that's all.
Thank you. Any questions on that update before we move on to community questions? All right, moving on. So, nice to see a bunch of questions here. Let's go one by one. So, I can't really tell who added this, but
Yeah, I can talk about this. So this is coming from some of the performance and scale testing that we've been doing on Azure. And I think we've discovered a couple of hotspots in core that would be good to talk about. But before we go talk about this, I was wondering if are there any known like cluster size restrictions, any known hotspots, like what kind of testing is core doing on the cluster size, or any limitations that you may have run in with the AWS provider? Um, Basically, what happens with Karpenter at the large number of nodes, like 2,000, 3,000, 5,000 or more?
I mean, that's
So
a
we
great.
don't have any. Sorry, go ahead, Saraf.
No, I mean, go for it. I think we just have to discuss this through and see. I know you have been working on this recently.
Absolutely. So we don't have any like specific guidelines in terms of like how much for the resource consumption, in terms of like how many resources you should give Karpenter when it is running at a specific scale. That kind of scale testing hasn't been completed yet. In terms of known constraints on cluster size, we know of a couple typical hotspots. The obvious one is consolidation at higher node scale. You need to have a full state map of the cluster in memory to do consolidation decisions, and that's an obvious hotspot for like a bunch of nodes. I would be very curious to know what kind of testing you've done and what resource hotspots you've been looking into, as we're also uh, we've also been looking at kind of improving Karpenter's performance in terms of
Yep.
just CPU cycles and stuff as we scale nodes. So
Yeah, I can talk about a couple. So consolidation is an obvious one. I'm thinking maybe we should develop some kind of guidance for, because it's probably like the current algorithm, correct me if I'm wrong, it's probably just unusable above a certain number of nodes. And I'm guessing the recommendation should be to use consolidation policy when empty from certain scale. I'm wondering if we should capture that, but consolidation aside, basically we've been using, profiling and continuous profiling, essentially the existing instrumentation for pprof that we, already have in core, which is great. As far as the tooling, one thing that worked really well for us is using Pyroscope together with Grafana. It actually didn't require any additional instrumentation on the Karpenter side, and it allows for continuous profiling essentially. So that was useful. As far as hotspots, there were a couple of things that came up after consolidation. Perhaps not surprisingly, node metrics at some point responsible for like 40% of allocation objects. I think that's because they replaced the whole set of node metrics is replaced like every 5 seconds or something like this. So at the significant number of nodes, this becomes a hotspot. And just as a proof of concept, we removed the node metrics controller from the list, passed into operator, and that eliminated at least this hotspot. I haven't actually looked at fixing this yet, just more proof of concept. What else? There were a couple of other things. I think there's like node claim disruption controller at some point does deep equal comparison on the stored node claim and the new node claim. And somewhat unexpectedly, this deep comparison generates quite a lot of intermediate objects. I think it's because of the visitation map that it uses internally. And for this one, there may be an easy fix because it compares the whole node claim, but it looks like in that context, just comparing the status may be good enough, or maybe even status like conditions. So I mean, I'll compile a list of those and share it either in an issue or on Slack, and we could take it from there. I was just wondering if there's any testing of this kind that has been done in core that we can benefit from. Like for example, with a Quark provider, I think I also tried just using Quark provider in core and scaling up to 5,000 nodes and scaling down. It seemed to work fine. And again, just wanted to compare notes on those.
Yeah, for the continuous profiling stuff, if you could write that up, I think that might make a good addition for docs. For the Karpenter guide, like how to do continuous profiling of your Karpenter. I think a lot of customers will get use out of that. I think that's a really good thing to have.
Will do.
And we've also done we've been identifying some hotspots as well. If you go look at the recent commit log, there's a bunch of small perfs where we like, cut down on the number of allocations, that kind of stuff. So yeah, we should compare notes, absolutely.
Okay, sounds good. I'm trying to think, Robin, did you have any specific questions in this area as well?
Not yet.
Okay. I think that's it then from our side. Thank you.
I do think I can go ahead and add real quick. On the provisioning side, at least, node count isn't necessarily the main performance bottleneck. It's typically more scheduling constraint complexity, particularly around like topology spread constraints, pod anti-affinity, etc. You're going to have slower provisioning if you have all of that configured on a 1,000 node cluster than you would if you had very simple pods on a 10,000 node cluster, for example. I'm pulling these numbers kind of out of my butt, but that's the gist of it.
Makes sense. Jack?
Jason, did that suggest that giving Kube Scheduler a ton of resource availability might help in those situations?
Well, it's not a Kube Scheduler that's the bottleneck at that point. It is Karpenter because we're doing.
Oh, it's the Kube Scheduler. It's the imported Kube Scheduler. Yeah, I see. Yeah.
Mm-hmm.
And it becomes much worse with the consolidation, right? Because the space that you need to explore is much wider.
Yeah, I mean, this definitely applies to consolidation as well, because as part of consolidation, we are running the scheduling simulation in Karpenter. So it's the same simulation. It has to do the same complexity for TSC and for pod anti-affinity and such.
Jason, maybe since we're talking about this, I think I saw something about timeout for consolidation attempts there, like making it time out after a certain period of time. Can you talk about this?
think Reed on the call. He's been the one who's been more actively working on this.
Is not.
Yeah, I know I've not been too closely tracking those changes. I don't know if anyone on AWS's side can speak better to it.
And for what it's worth, it looked like capping the amount of time it would try to consolidate and then kind of giving up so that you can let other controllers, disruption controllers, make progress. Something like this.
Yeah, I believe that's the case as well, but off the top of my head, I don't think I can provide much more detail than that.
Yeah, I don't have full details either, but I've been talking to Reed a little bit about this. At a high level, it's basically that instead of just waiting forever in order to have that perfect scheduling and consolidation decision done, I think we're just like stopping early and like timing out so that at least we can make progress. So it's just a matter of whether we can go ahead with a somewhat suboptimal decision and just instead of just like waiting for a really long time and never arriving at a perfect decision. And again, I think like Reed is the perfect person to talk to about this. Like we've made a bunch of enhancements on the consolidation side. If you could create an issue with the findings that you have, Alex, I think it will be really great because like we can both compare notes as well as try to get some of this prioritized.
Yep. Yeah, we can do that. Sure. One more point I'll mention, like on our side, I think it was actually less performance and a little bit more resource consumption. Because even looking at the CPU profile, it looks like, again, from certain number of nodes, it was spending like maybe half of its time, CPU time in GC, garbage collection, which means that we should probably take a closer look at, allocation, object allocation, and that's where we've tried to focus a little bit.
Yeah, I've been looking at the same stuff here on AWS side, so we'd be good to sync up with. Same with Jonathan. I think he's also been working on that for a bit.
Great, good timing then. I'll share the notes.
If there are no other questions on this, we can move on. Thanks, Alex, for bringing this up. I think this was a very interesting discussion. Moving on to the next one.
Sorry, I
Yeah.
have another question.
Go for it.
Not sure if I missed something, but do we have the scale test that is running on AWS right now for Karpenter, like for large clusters?
Your question is, do we have the one that's running in the Karpenter provider
Yeah,
you're asking about?
yeah, like not Quark, but end-to-end for a large cluster.
No, that's not has not been imported into the like I guess to run it against Quark. I mean to that effect, the scales for that for those tests are only up to like 500 nodes. But I mean, yeah, to that effect, we have not actually migrated that over just yet either.
Yeah, I think generally too with Quark, we want to be a lot more ambitious about the type of scale testing we're doing than what we had been doing with real nodes on AWS, just because it doesn't have quite the same cost.
Yeah, that's been one of the main hesitations. We do have a set of tests that are based around I guess to try to get a performance. So we try to do like complex scheduling requirements similar to what Jason had brought up around topology spread and anti-affinity simple provisioning and such, and compare those out like times that we get, which kind of like gets you somewhat close to that. I can link that in the chat as well. But that's that we have running in the Quark provider, but it's not necessarily the same as the one we have in the AWS provider.
I also don't think that those tests currently look very closely at the CPU and mem utilization metrics. So we don't have good, if you're interested in, we should have tests that do that, and we don't. So if someone wants to add those, would be fantastic. I don't know exactly how you would set that up properly today, but especially for the Quark stuff, if we want to add a better end-to-end Quark test that like tests our CPU utilization and stuff, I think that'd be a useful
Yeah, I mean,
add.
that's certainly part of the long-term vision with the work with the Quark provider.
Looks like we addressed that. So moving on, does anyone want to talk about this?
Yeah, that's my item. And this is AWS specific, but maybe it's relevant to the other providers too. An ISP in this context is Instant Savings Plan. So AWS offers Instant Savings Plan, and Carpenter, we can be made aware of them and use them. However, the problem is that the plans are regional and clusters, you can have multiple clusters in a single region. So if you want to split a plan across multiple clusters right now, you have to manually slice it, which is not great. If you have like 1,000 node instant savings plan and you slice it across 2 clusters and say limit each of them to like with a node pool that has a limited capacity so that you're making sure that you're drawing the nodes out of the savings plan. If your clusters auto scale, one cluster might get bigger than the other, and then you've used up the savings plan in cluster A, but the savings plan still has free nodes in cluster B, so then you're provisioning nodes inefficiently and out of the savings. Can Carpenter be made aware of this? Has anybody thought about this? Are people using instant savings plans at all with Carpenter? Like, I'm curious if any other customers have hit this. Um, and what people think about this.
I mean, this isn't something that's Carpenter's natively aware of today. I mean, to Garvin's point in chat, does sound very similar to what we did with ODCR. So Carpenter does now have native support for on-demand capacity reservations where we are aware of capacity reservation pool depth. And we'll prioritize until we have exhausted that capacity reservation pool. But yeah, it's not something that's supported today. It does sound like an interesting use case. I'm not sure if the AWS APIs are available to understand what the current consumption of an instant savings plan is. It's just not something I've looked into. But yeah, I mean, it sounds like today, at least, if you wanted to guarantee, I guess, fair consumption across multiple clusters, partitioning them in the way you described is probably the best approach at the moment. But yeah, I think this would be something that would be interesting to explore and potentially as an expansion to what we did with ODCR.
Okay.
Yeah.
I'll probably write up some issues around this then.
Yeah, if you can like search up the ODCR one, you can take a look and see what's going on there and come up with an issue with that.
I guess I did have a question here though, is how are you making like, I guess today Carpenter wouldn't necessarily be aware of the fact that the pricing difference are, I guess, applied to these instance types. So how are you guys, I guess, how are you necessarily managing that, if that makes sense?
We're going to use weights in the node pools.
Gotcha, okay. And then just like capping it based off of limits.
Yeah, I mean, we know the size of the instant savings plan at the time of creation, so we can create node pools that have the same setting effectively, but that's all manual and not great.
Gotcha.
Yeah, I guess at a high level, like the ODCR implementation allowed us like Carpenter to ask how much was left and then try to pick it up. So similar to ISPs, I guess on chat, but yeah.
I wasn't aware of the fact that, so one of the things with this is like, I wasn't aware that there was an API that directly gives you the number of like instances that are actively being like used as part of the savings plan. Is that something that's available today?
Sure. We might have to look. I thought they might be able to, but I could be wrong.
Yeah, as far as I was aware, that like this is kind of one of the use cases for node overlay as well, is that like we're not necessarily able to be aware of this. There isn't like a direct API. I could be wrong there, but I don't know, maybe something to consider. I was under the impression that you couldn't necessarily get this information back from AWS.
Yeah, I mean, there are potentially options if you're matching against all instances. Like, if a savings plan matches all instances of a certain criteria, you could simply list all of the instances in the account. That would require the expansion of the IAM permissions that Karpenter currently has today. I'm pretty sure describe instances is limited based on tags for the AWS provider, but there are possibilities even if there is no native EC2 API.
Right, right. In our case, Karpenter would be the only thing doing the EC2 provisioning. So yeah, a tag-based approach would be fine.
Mhm.
All right, is there anything else before we move on to the next one?
Nope, that's good.
Right, thank you. Does anyone want to talk about this?
Yeah, I can frame this. So hey everybody, I have been pestering Jason on Kubernetes Slack about Karpenter plus DRA. So this is something that Jonathan opened up a while back. Looks like 14 months, 13 months. And I would love to get this sort of accelerated so that we can have a really great Karpenter DRA story in the near future. Cluster Autoscaler is releasing its sort of second phased introduction of DRA with 133 upcoming. So DRA is a huge collection of new Kubernetes features and APIs. So it'd be hard to summarize here, but I'd be happy to if anyone has any questions, obviously. But also happy to talk on the Karpenter Slack or on DM or whatever on Kubernetes Slack. But I think we have a nascent sort of idea of how we might do this. And so I just wanted to kind of send a shout out to anyone who wants to join this effort. Jason, I don't know if you have an appetite to like officially formalize something where we meet every week for a half hour or something and divide and conquer.
Yeah, I'm on board with the idea. I think as far as the bandwidth I can dedicate to this, because I am the one that's tracking this from the AWS side at least.
Yeah.
I don't think I'll be able to dedicate a ton of bandwidth to design and implementation until probably early July. But I'm more than happy to start something and we can start getting together and going on a direction for a design and yeah, see where we want to go from there. And if anyone else wants to start picking up implementation work too, that'd be fantastic.
Yeah, great. I think that would be totally fine. We can fill in terms of the near term energy and cycles to put forth some sort of DRA specific design recommendations, and then you can sanity check that and bring us back to earth with what's actually going to be possible in Karpenter.
Yeah. Yeah, I think that the thing with DRA that definitely makes me a little apprehensive is the wrong word, but a little nervous about how the implementation is going to go is we don't get the same benefit of being able to just use the existing scheduler implementation. We're re-implementing a lot. So I definitely think this is going to be a bit of a feat, but I'm looking forward to seeing what we can do with it.
Yeah, I mean, I think I think I agree with that based on my sort of medium understanding of Karpenter architecture, that it's going to be a lot harder than Cluster Autoscaler, but it's also going to be a lot more powerful. So that I think the long tail is really going to tell the DRA story. So DRA, just super briefly for folks who aren't aware, it defines a new set of APIs in Kubernetes that inform the scheduler about flexible topologies. It allows pods to do all kinds of sort of first-class multi-tenant topological local scheduling. It's hard even to say it in a single sentence. But with a heterogeneous provisioning actor like Karpenter, it's going to sort of render that flexible environment like at runtime, which is going to allow sort of like eager optimizations of topologies. Whereas now with something like cluster autoscaler, you have more or less static cluster configs. And so you need something like the scheduler to properly pack those, and DRA allows you to express those topological constraints in ways that the device plugin APIs can't. But Karpenter will allow that to happen like from starting from zero, I think, which is going to be really powerful. Cool. So I guess mostly this is just a shout out. I'm here with Alima. We're both working for Microsoft. But I don't think this is going to be specific to the Azure provider or anything. So we'll probably be sticking around.
So is the
Awesome.
sorry, just checking, is the next step here RFC? Because I know there has been a lot of buzz around DRA, but there have also been a lot of changes upstream. So do we need an RFC to just kind of get the lay of the land in terms of what we need to do in Karpenter?
I think that's where we were discussing maybe setting up a weekly meeting to try and drive that RFC, because DRA is going to be a pretty huge, it's a pretty huge change to Karpenter scheduling behavior. I think it's going to be extremely powerful, but yeah, it's going to take a decent bit of work to get right. So yeah, I'm definitely on board with setting up something weekly if we want to sync on Slack to try and figure out how we want to drive this.
Yeah, great. And I can look for maybe a SIG Autoscaling funded Zoom channel or something, if that'll help.
Sure.
But yeah, I think I agree, Sarv, that the next step would be an RFC. Probably not next week arriving or anything like that, but I don't think there's any implementation work that can be done without the RFC process.
No, short of POCs, but
Yeah, I think what I was trying to get to is, do we need like a RFC for RFC basically? Because I mean, this is a huge thing, right? So I'm not sure if we are gonna have like the final RFC ready, because I'm going to assume that it's going to be a very big thing. So if we want to come up with some initial draft of, okay, hey, you know what, at a high level, these are the things that we want to do, and then kind of have that bigger RFC basically divided into different chunks, which we can kind of try to either do in parallel or have multiple people work on. Again, I mean, not trying to prescribe a particular process, but just something to think about, and in case it's going to help.
Yeah, if I were to speculate how it would go, it would be probably the first bit of effort is figuring out how is this actually going to be possible, which could then inform some decisions about how we would go about actually doing that work over a long period of time, prioritizing not breaking existing users. I think prioritizing introducing the fundamental bits of the DRA structured parameters feature set first, because again, there's a lot of different DRA features that are in various states of alpha, beta, and in GA, the structured parameter stuff is going to go GA in 134. But what Cluster Autoscaler has successfully done is sort of like picked off the very smallest amounts of functionality and done those first. And it's just going to be iterating gradually with subsequent releases to add more and more of that. So I think a pattern like that would be useful, because like we're going to see here, if we don't do it right, it's going to have effects on, it's going to be a huge, powerful new feature set that almost nobody's going to use right away. So we have to be aware of that. Like the priority is going to be to keep the existing users functional and performant.
yeah, I think, and this is where it's very timely with a lot of the work we've been doing into performance and performance monitoring and benchmarking and such. Because yeah, this is definitely a bit of a risky feature in terms of incurring performance penalties in our scheduler. But so yeah, very timely that we're starting to build that out more and more.
Yeah, absolutely. One last thing from me. If you guys decide to like start this discussion in a channel or something, I would love to participate. I don't yet know how much time I'll be able to dedicate. But this is something that I've personally been very excited about. So I'd love to just keep a close eye on this. All right,
Great.
no questions on this. We'll move on to the next one. For this,
Yeah, so I'm trying to get the cluster API provider updated right now, and I'm running into like some weird, some weird issues that I have a feeling are related directly to cluster API. But one of the things that I'm curious about is like when a node, when the core Karpenter calls the provider interface with the create, if I fail or if the provider fails to create the node claim properly at that point, like what is Carpenter Core's reaction to the error being passed back there? Because it seems like I'm running into a situation where I'm getting like more nodes created than I expect, and I have a feeling it's a problem with my logic. But I'm also seeing like several error messages coming back from the core parts of Carpenter, and so I'm curious, like, does it just try to recreate the node claim, or does it back off and try to do it again? What's like the mechanism there?
So it depends on the type of error you return back. I forget the name of the wrapped error we send. But so one type of error will allow you to basically just delete the node claim. So in the AWS provider, for example, this is what we use when all of the different instance types were iced. So we know we won't be able to create a node claim, so we just delete it. If it's like a transient networking error or something that caused the create failure, that's where I believe that's just a standard error returned back, and that's where you go into retry with back off. So that might be where you're seeing multiple nodes being created.
That's probably it. And then because with cluster API, I'm doing something where, like Carpenter is like, it talks to the API server, and then like in the cluster API portion, I also talk to the API server, and it might be a different API server to try and make resources. And I might need to like requeue requests on the other side. So if I return an error, can I expect that it's going to like requeue the same node claim? Like, will the details stay the same for the node claim, and it'll just try again basically after a back off or something?
So it doesn't, I guess it depends. This is where we've had what I think is maybe a little bit of confusing naming. The cloud provider node claim that is returned back to upstream. So with the details for like the node that you just launched, that is not persisted across requeues.
Okay.
The original node claim is.
Okay.
The node claim that drove the launch is persisted, but not
Right.
details from the previous failed attempt.
Okay.
Is that kind
Okay.
of what you were asking?
Yeah, that absolutely helps. I'm just trying to understand this logic a little better, and I've looked through the core Carpenter code, but like I'm not absolutely familiar with it yet. So I figured, since the meeting was happening today, I'd just come and ask. I think this helps what I'm trying to do though. So yeah, hopefully I'll get that updated in the near future here. Thanks.
Yeah, no problem.
I'm just curious, Jason, is this something that we can put into docs? I mean, I'm not sure if it really needs to belong in like a user-facing documentation, but like maybe like a developer documentation.
No, I think this comes back to kind of what we discussed last working group, putting together a doc about this is the contract that a cloud provider needs to implement when implementing the cloud provider interface. Because right now it is only loosely documented. Some things are not documented. Like this error, like these different error types, for example, I don't think are actually documented anywhere. Like you can discover the error types by going through the code, but yeah, I don't think there's any solid documentation. So I could eventually see this being like a docs page in our development guide.
A good point.
Yeah,
I
so
got
I
it.
dropped a link in chat there, but I did start an issue about the provider contract stuff, and I've actually I ran into the first thing, which was like, just the notion that the node that the provider is responsible for like marking the node class as ready. That was kind of like the first thing I ran into. But now, like one of the next things I'm running into, and this is kind of I wasn't necessarily going to ask this today, but like, Carpenter expects there to be the carpenter.sh like unregistered taint or whatever on the nodes that are created. And so like I'm kind of wondering like whose responsibility is it to put that taint on the node? Is it like the provider's responsibility to inject that taint into the node creation then?
Mhm.
Okay. I see
Yeah.
Jason nodding. So, okay, cool. So I'll add that as like another message here, but I was going to try to just like keep using this open issue to keep documenting things that I was hitting that might be areas that we want to put into contract documentation. And I also linked in the issue to cluster APIs, one of cluster API's contract definitions, because they have like a very similar mechanism where it's like it's a contract that the provider has to match, and it's based around Kubernetes objects and everything. So there's work the provider has to do, and if they do that, then they'll match the contract accurately. So I think like that could be one of those things where, just like Jason was just saying, eventually maybe we could get to a documentation page that says, here's the contract for like a node claim. Here's the contract for a node class. Here's the contract for a node. Here's the contract for node pool or whatever. And then it'll be much easier for new providers to know exactly like what they're responsible for, what they have to do and everything.
Yeah, I think we're at a point where it's probably practical to start putting that together. I mean, this has all been relatively stable since the V1 release. So I don't think we would be rewriting it every time we do in a minor version. So
Let's hope not. Yeah. But
no,
like,
no.
yeah, I'm doing some updates to go from like 0.37 into like, 1.1 and then 1.4. And it's like, yeah, some of the changes that went in the 1.0 stuff were big enough that, yeah, they broke some things that I was like, I just wasn't even aware of, basically.
Yeah, 1.0, absolutely. I do think it's been relatively stable since then, but yeah, please, if you find anything, let us know on your issue. I'll also contribute to that issue as I find things that are potentially surprising.
Yeah,
I don't
cool.
guarantee I'll remember everything because some of the stuff I just know and don't realize is surprising.
Right. And that's why I'm trying to document it as I'm doing this current upgrade, because I'm hitting things that like I had never seen before. So it's like, okay, as long as I'm hitting it, I might as well document it.
Yeah. No, appreciate it. I think this should form a good baseline for that eventual docs page.
And we'll try to help from the side of the Azure provider because yeah, we definitely hit some of those, during the upgrades, of course. So
Awesome. Yeah, thank you. And yeah, the minor upgrades after 1.0 have been pretty trivial so far, but
Yeah.
yeah.
That's good to hear.
Cool.
I'm glad you brought this up, Almiko. I was looking at the notes from last week and I was actually curious that like we kind of took that as an action item and wasn't sure who was going to work on this. So thanks for putting this together in an issue. All right, moving on to the next one. Just opening this up. Does anyone want to talk about this?
Yeah, I think this is my PR, and I'm quite new to the code base. I was just wondering if anyone can point me in the right direction to see if the changes are what we anticipate and expect, or am I completely in the wrong direction?
Sure. So are you just looking for a reviewer for this PR?
Yeah, I mean, any feedback, if I'm heading in the right direction, if this is good. Yeah, I do need to refactor a little bit, I think. But yeah, main point being the logical approach, if this is what should be done for this issue.
Got it. Yeah, I could take a stab at this and like do an initial pass before like Jason, Emmanuel, or any other maintainer takes a look.
Yeah, that would be great. Thank you, sir.
Assignments about the review. Okay. Darwin, you want to talk about
Hey.
this?
This is a relatively small PR. It's just to support Nitro enclaves. The caveat here is that it doesn't fix or address the issue where some part of the node's resource is going to be carved out for the Nitro enclave. It simply addresses supporting it and having the launch template created by Karpenter actually pass the option of enclave option enabled. That's it. It won't do any of the other stuff, which I think no overlay might cover. Yeah.
Would it be possible to discover
I imagine, so you say the resources are carved out. I'm not too familiar with Nitro enclaves, but does that just mean like when you configure an instance to launch into an enclave, it might take off 100 megabytes of memory, something like that? Is it possible
Yeah,
to ever what that value is, or is it kind of similar to what we need VM memory overhead percent for?
yeah, it's kind of dynamic. I think I need to double check, but I think like you specify within the user data, so I don't think it can easily figure it out with like because it can vary depending on instance type and stuff like that. So I need to double check that, but essentially, I'll double check and I'll add to it. But from what I remember, it's not something that is standardized that we can figure out ahead of time.
So I was under the impression, correct me if I'm wrong here. I was under the impression that you need support for huge pages to run Nitro enclaves. Is that the case?
That is new to me. I mean, you could be right. I have no idea. I can double check on that. I didn't think that was the case, but
Yeah, but there were some people, at least internally, that had mentioned to me that they want support for Nitro enclaves, exactly like how you've defined it here. However, there is a prerequisite of needing huge pages, to at least configure huge pages on these nodes, and then obviously Karpenter being aware of those resources. I just wasn't sure if you had any more additional context on that. I myself don't have that much context either.
I can take a look. But I guess those all fall into node overlay though, right? Like I guess at the very low level, you aren't able to configure huge pages anyways right now in Carpenter.
Right.
So regardless of it, if it's needed, this is simply passing an option, assuming you can somehow figure out on a user data set how to make a huge pages happen and stuff like that.
Yeah, I guess it was just more of a question of like, if you get these resources that you want, these Nitro enclaves, is it going to, I mean, I guess it wouldn't necessarily, it would just be the same functionality with other extended resources today then.
Yeah, I'll add a little bit more context. I started this work, but then I wasn't the one actually adding the enclaves, so I didn't know a lot of the details, but I'll double check. I'm pretty sure the CPM memory was defined in like user data, but yeah, I'll add a little bit more information around the CPU memory and then any huge pages. Yeah.
Thank you.
All right, if there are no other questions on this, I think we are at the end of our agenda for today. Does anyone have anything else they want to bring up?
I just want to say big thanks to everybody for showing up. I think this is the biggest working group meeting we've had in a while, and it's great to see everyone coming out and supporting the community. I think we're going to do some great stuff in the next couple of months. I'm excited.
Yeah, I agree. I think this is the most fun conversation that we have had in these working groups in a while. All right, last call for any other questions. Cool. I think we can end a little early today. Thank you all. Thank you all for attending, and see you all next time. Bye.
Thank you.
Thanks, everybody.
Thanks.